Hi there, grade 8. Our lesson for today is about multiplication and division of rational algebraic expressions. So last time we learned about simplifying rational algebraic expressions, and we were able to define what's a rational algebraic expression is, and we compare this with fractions. So we define RAEs, or rational algebraic expressions, as a fraction whose numerator and denominator are polynomials. So now it's the same idea on how we multiply and divide rational algebraic expressions with fraction. So before we proceed with multiplying and dividing RAEs, we will recall how to multiply fractions. Okay? So multiplying fractions is done by multiplying the numerator to numerator, denominator to denominator. But in the event that each given here has common or has factors and they have common factors, so we have to cancel their common factors before we multiply numerator to numerator, denominator to denominator. So for instance, in number 1 here, the factors of 21 are 7 and 3. So we'll just rewrite 5 because 5 is a prime number. And then 55 is 5 times 11 all over 6 times 3. So the next thing that we will do is to cancel the common factor. So we cancel 5 and 5 here, 3 and 3 here. Now, in canceling common factor, we just do that vertically or diagonally, meaning we are not allowed to cancel the same factors on both the numerator or on both the denominator. So there should be one common factor on the numerator or on the denominator, or vice versa. Okay, so after canceling the common factor, we will now multiply numerator to numerator, denominator to the denominator. So we will multiply 7 and 11. So we'll get 77, and then 6 on the denominator. So this is the product now. For number 2, we will factor 77. And the factors of 77 are 7 and 11. For 39, we have 3 and 13. And then 13 is a prime number. So we'll just rewrite 13. 22 is 2 times 11. And then cancel the common factor. So we have 13 and then 11 here. So we have 7 all over 6. Now for division, before we work on the factor of each given, make sure that you have to get the reciprocal of the divisor and then shift to multiplication. So the factors of 35 are 7 and 5, while the factors of 72 are 9 and 2. And then we will shift to multiplication as we get the reciprocal of 21 all over 8. And that's for a while. So this should be 8. So we have 8 here. And then 21 is 7 times 3. And then cancel the common factor. So cancel this 8 and then 7. So multiply the remaining expressions, numerator to numerator, denominator to denominator. So we have 5 all over the product of 9 and 3, which is 27 there. And then again, we'll write the factors of 27. So it's 9 and 3 all over the factors of 44. We have 4 and 11. We will shift to multiplication, but make sure that you will interchange the position of this. So 11 will be on the numerator, and denominator will be, and that numerator will be on the denominator. then cancel the common factor. So we have 3/4 as our final answer. So class, exactly the same procedure as what we did in the multiplication and division of fractions in multiplication and division of rational algebraic expressions. So the first thing that we're going to do is to rewrite each given in factor form. So meaning we're going to write the factors of each expression. Now, for the first numerator, it's a quadratic trinomial, but it's easier for us to find the binomial factors if we will move out first the common monomial factor. And that common monomial factor is 6. And then we will divide each of these terms by 6. So this becomes 10x squared. And then 18x when divided by 6 will become 3x. And then negative 6 divided by 6 is negative 1. And then we will just write the factors here. So we have 6. And then the binomial factors. So for 10 here, so we can write 2x and 5x. Okay, since this is negative 1, so we made use of 2x and 5x. Now, the only factors, of course, of negative 1 will be 1 and negative 1. So we have to find out as to where are we going to place the negative sign. And we have to know that the middle term here is 3x. So since this is 1 times 5x, we'll get 5x. And then this is 2x times 1, we'll get 2x. And the difference will be 3x. So this matches here. So this has to be positive, and then this must be negative to obtain the 3x as the middle term. And then the first denominator has a common monomial factor equal to 3x. And if we divide both terms here by the common monomial factor, so we will have 2x. 3x divided by 3x is 1. So these are the factors. And then second numerator, so it's a quadratic trinomial. So the factors are two binomial factors. So by trial and error, we'll have 5x and x as the factors of 5x squared, 1 and 1 for 1. Everything is positive here. So both binomial factors will have an addition operation. And by inspection, the middle term is 6x. Okay, so this is 1x plus 5x, so we'll get 6x. And then here, the two terms here have common monomial factor, and that's 2. So when we divide both terms by 2, we have 25x squared minus 1. And this is still factorable. So the factors of this along with this constant factor will be placed on this portion. So we have 2 here. And then the factors of 25x squared minus 1, we have 5x plus 1 and minus 1. Now, after identifying all the factors, so the next thing that we will do is to cancel the common factor. So we have 5x plus 1 here, and then 2x plus 1, 5x minus 1, okay? And then this 6 is equal to 3 times 2. So we will cancel this 6, but there remains x, no? So the final answer for number 1 will be the remaining expression on the numerator all over the remaining expression on the denominator. So we have x plus 1 all over x. Now for number 2, the factors of the first numerator. will be a binomial factor and a trinomial factor, since this is the difference of two perfect cubes. And the binomial factor is the cube root of both terms here, and then we will carry the subtraction sign here, or the subtraction operation. So cube root of 64x cube is 4x minus cube root of 27, 3. And then the trinomial factor, first term is the square of 4x here. Then the product of the two times negative 1 will be the middle term. And the square of negative 3 will be the last term of this trinomial factor. Now, this trinomial factor has a common monomial factor, and this one is also a quadratic trinomial. So let's find out what will happen if we will divide each of these terms by 2. So we have 16x squared plus 12x plus 9. And class, this trinomial factor is exactly the same with this one. So we will just rewrite this along with the constant 2 factor on this portion. So we have 2 16x squared plus 12x plus 9. Okay. Now, this 32x squared minus 18 has a common monomial factor 2. And as we divide both terms by that common monomial factor, so we'll have 16x squared minus 9. And this is still factorable. So the factors are two binomial factors of the same terms. One is addition, the other one is subtraction. And that can be obtained by extracting the square root of both terms here. So the factors are square root of 16x squared, and then plus square root of 9 here, minus 3, all over. This one, class, is a quadratic trinomial. Okay, so the factors are two same binomial. Okay, such that the first term is the square root of this, while the last term is the square root of 9, and then we will consider the minus sign here. So square root of 16x squared is 4x minus square root of 9, 3, quantity squared. So we will cancel the common factor now. So on the numerator, we have 2 4x minus 3. 1, and then this is the other one. And then we also have 2x minus 3, which is denoted by square of 4x minus 3. So we will cancel the 2 4x minus 3 here and this one. And then we have this trinomial factor, the same with this one. Okay. 2 is the same with this 2. So the remaining expression is the answer. So we have 4x minus 3 here. Next. Okay. So for number 3, the first numerator is a quadratic trinomial. So we have two binomial factors for that. Okay. So we can consider x and 6x. If we consider x and 6x as a factor of 6x squared, and the middle term here is x, so we're going to place 5 here and 1 here. And then we will make 6x positive. So when we less this by negative, or when we less this by 5x, we'll have x here. So this is positive 1, and this one is negative. So 1 times 6x equals 6x plus negative 5x equals x. So these are the factors of this quadratic trinomial. Now, the first denominator is the difference of two cubes. So the first binomial factor for this is the cube root of both terms here. So cube root of 216 x cubed is 6x, while cube root of 125 is 5. So this is minus 5. And the trinomial factor first term will be the square of 6x here. So this is 36x squared. And then the middle term is the product of the two terms here times negative 1. So this is plus 30x. The last term is the square of negative 5. Now, this is exactly the same with this one. So we will just rewrite the second numerator plus 25. And then copy x plus 1 and then cancel the common factors. So we have 6x minus 5, x plus 1 here. So everything is canceled, class, and we represent that by 1. Okay? If everything is canceled and the operation is multiplication or division, we will represent our final answer by 1. On the other hand, if we are performing addition or subtraction and everything is canceled, we will represent that by 0. Okay? So for number 4, the first numerator is the difference of two squares. So the factors are the same two terms but differ with the operation. So we have two binomial factors here. And the two terms are the square root of the two terms here. So we have square root of 9x squared and square root of 1. This is addition, this is subtraction. Okay? Now, the first denominator is a quadratic trinomial. So we have two binomial factors for that. Now, we will consider either of the two factors here can be factors of this trinomial, quadratic trinomial. Why? Because 3x is one of the factors of 6x squared. So we can place 3x here. If we have 3x as one of the factors, so the other factor should be 2x. And since this is negative 5, so 1 must be placed here, 5, and then the other one is 1. So either must have a negative sign. Since this is 13, if I'm going to place 5 here, and when 5 is multiplied to 3x, it's 15x, and that's near 13x. Okay? Since this is positive, maybe 5 is positive and 1 is negative. So as we check the sum of the OI here, I mean the product of the outer terms is 15x, while the product of the inner terms here is negative 2x. As we combine them, the result is 13x. So these are the factors of the first denominator here. Now we have another quadratic trinomial here, and we may consider 2x plus 5 as one of the factors because our goal here is to cancel common factor. So we may consider 2x plus 5 as one of the factors of this quadratic trinomial because 2x is one of the factors of 2x squared and 5 is one of the factors or considered as factors of negative 5. So if one of the factors is 2x plus 5, the other factor should be x minus 1. And we have to verify if the middle term 3x here should match with the combination of the OI here. Like 2x times negative 1 is negative 2x, while 5x times x, 5 times x is 5x. So 5x minus 2x is 3x. So these are really the factors of this quadratic trinomial. And then we will write as is 1 minus x. And then cancel the common factors. So 3x minus 1. And then we have 3x minus 1. We also have 2x plus 5 here. Now look at this x minus 1 on the numerator and 1 minus x on the denominator. They're exactly the same terms, but they just differ with the sign. If we like move the negative factor, for instance, of this x minus 1 and divide the negative factor by divide both of terms here by the negative 1 factor. So we have negative 1 for instance here, and we will divide x by negative 1. We have negative x. And then negative 1 by negative 1, we have positive 1. Now, negative 1 times quantity negative x plus 1 is the same with x minus 1. When you distribute this negative 1 to both terms, you'll come up really with x minus 1. Now, the expression inside the parentheses, negative x plus 1, is the same also with 1 minus x. So we can cancel this 1 minus x and this negative x plus 1. But take note that the negative 1 factor remains. So the answer for this will be negative of 3x plus 1. Okay? So for number 5, we're now going to proceed with division of rational algebraic expressions. So same with what we did in the previous examples, we're going to rewrite each expression in factor form. But here, make sure that you get the reciprocal of the divisor, and then we will shift to multiplication. So the first numerator is a quadratic trinomial. So the factors are two binomial factors. So if we're going to write 2x here and 5x here, take note that the middle term here is 23. So if we place 5 here, of course, this should be 1. And this is positive. So it should be positive 5. So that we'll have 5 times 5x equals positive 25x, which is very near 23x. And this should be minus 1. So we have 2x times negative 1, negative 2x. And then 5 times 5x, 25x. So we'll get 23x as the middle term. Now, class, we will no longer factor this first denominator. Why? Because this is exactly the same with the second denominator. And take note that we will get the reciprocal of this. So this second denominator will be placed on the numerator, and we can cancel this along with the first denominator here since they are the same. Okay, so we will just rewrite 10x squared plus 31x plus 3. And then we will shift to multiplication, but make sure that we get the reciprocal, or we rewrite the second fraction by expressing its reciprocal. And this is the difference of two squares. So the factors are two terms which are actually the square root of the two here. So we have 5x and 5x, square root of 25x squared, square root of 1 is 1. So this is plus, this is minus. And then we will cancel the common factors now. So we have 5x minus 1, this one. So the remaining expression is 2x plus 5 all over 5x plus 1. And this is our answer. Okay, for number 6, it's still division. So we will factor 81x to the fourth minus 1. And this is the difference of two squares. So we have 9x squared plus 1. The other one is 9x squared minus 1. Take note, class, that this is still factorable. So we will write all the final factors of the first numerator here. And the factors of 9x squared plus 1 are 3x plus 1 and 3x minus 1. So these are the final factors of the first numerator all over. Now, this is a perfect square trinomial, the denominator. So the factors are the same two binomials. So we have two same binomial factors such that the first term is the square of 9x squared while the last term is the square of 1. And this is difference of a square since the middle term is a minus sign. So square root of 9x squared is 3x while square root of 1 is 1, and then this is quantity squared. So we will shift to multiplication, and we will get the reciprocal of this divisor. So we will write 3x minus 1 on the numerator. and then the factors of this perfect square trinomial on the denominator. So since this one is the same with this one, they just differ with the operation. So they will have the same terms, but it's the sum of the squares. Okay, so square root of 9x squared is 3x plus square root of 1 is 1 quantity squared. And then we will proceed to cancellation of common factors. Now, guys, we have 2 3x minus 1 on the numerator, which is the same with quantity 3x minus 1 squared. So we will cancel the 2 3x minus 1 on the numerator and this one. Also, 1 3x plus 1 here, and then 1 3x plus 1 is cancelled on the denominator. So the answer for number 6 will be the remaining expression on the numerator, which is 9x squared plus 1 all over 3x plus 1. There. Okay, more examples. So for number 7, it's a quadratic trinomial, but it's better if we move out the common monomial, so it's easy for us to work on the two binomial factors. So the common monomial factor is 5x. So it's 5x here. And then we will divide all the terms by 5x. So we have x squared plus x minus 2. So it's easier now to factor x squared plus x minus 2. And we will write the factors below here. So we have 5x and then the factors of x squared plus x minus 2. So of course x and x and then 2 and 1. So this is plus 2. This one is minus 1. Since the middle term is positive. And then we have common monomial factor for x squared minus x, and that's x. So if we divide both terms x squared minus x by x, we have x squared divided by x equals x, and then negative x divided by x is negative 1. And then we'll shift to multiplication, and we'll get the reciprocal of this. So the factors of x squared minus 12x plus 11 will be placed here. And that one is a quadratic trinomial. So we have two binomial factors for this. So we have x minus 11 and then x minus 1. So this will match with negative 12x. Okay, for this one, the factors of this, we have common monomial factor for this. So we have 5 as the common monomial factor. And then as we divide all these terms by 5, we have x squared plus x minus 2. So it's the same factors with this one. Since we have factored this out, so we will just factor this out as is. So we have x plus 2 and then x minus 1. And then cancel the common factor, x minus 1, x plus 2. And then we have, we also have this 5x here is the same with this of x at 5. So we have 5x here, and then we also have 5 and x here, so we can cancel 5x, x and 5 here. So the remaining expressions now is the final answer, which is x minus 11. For number 8, so the first numerator is a quadratic trinomial. So we have two binomial factors for that. So we have 2x and then x here. So we have 1 and 1 here. So we just have to find out which is positive and negative. If this is positive, this is negative. And the middle term is negative x. So as we combine negative 2x and positive x here, we'll have negative x. And then we'll write as is 1 minus 2x. And we'll shift to multiplication, and let's get the reciprocal of the divisor. So we will just write x squared plus x plus 1 on the numerator, since this is considered one of the factors of this polynomial, because this one is the difference of two cubes. So the binomial factor is the cube root of both terms, and we will place it here. So cube root of x cubed is x, cube root of 1 is 1. And then the first term of the trinomial factor is the square of x, while the middle term is the product of x and negative 1 times negative 1. And then negative 1, the square of negative 1 is the third term. And then the next thing is to again cancel the common factor. So we have here. So the remaining expression is the final answer. So we have 2x plus 1 all over 1 minus 2x. So that's how we multiply and divide rational algebraic expression.